Well, share my screen. Chat. Minimize this. All right, ready. Let's see who just joined. All right, we have Garen, we have Elisa. Let's give everybody a couple more minutes. Hi, Elisa. Hi, Josh.
Hi, Professor. How are you?
Great, thank you. Okay, Rook Swan. Aiton. Hi, Aiton. All right, just give everybody a minute or so. Oh, beautiful day outside. Just thinking maybe we could do these out, do a outdoor session. Hi, Oriole. Welcome. Hi, Jarrett. All right, let's get started. All right, welcome, everybody. Let's see. Yeah, we're getting started on our 12th week, and there are no more assignments, or I guess no more individual topic assignments. All the assignments that are left to the end of the semester are project-based assignments, which for this week you are tasked with working in a team on designing and creating a database for your project. And you might have already done this. I see that some folks have actually already submitted this, so that's great. But you do have till April 16 to come up with a design that's, I guess, not this Friday, but the following Friday. And the intent is that you by next Friday, again, not this Friday, the next one, a week from this upcoming Friday, you'll come up with a design, a UML class diagram that captures a design of something that you want to build. And a lot of you already have done this, which is great. Definitely please have it by April 16th. And then a week after that, you're expected to have created some code that allows you to access this data on the database programmatically, whether you use JDBC or Python, Django, or whatever you want to use to talk to the database. It's really up to you. Also for the database part, right? We've spent most of our time in talking about relational databases, and in particular, we've been talking about MySQL. But that's for the assignments. In the database, in the project, it's really open-ended. If you want to use something other than MySQL, please feel free to explore there. Right? If you want to try out, Oracle or SQL Server or Postgre, definitely, don't feel like you're limited only to MySQL. Or even if you want to try out some of the non-relational databases that we mentioned last lecture, so definitely feel free that you can explore that as well. And so any non-relational database will do, and in specific, definitely MongoDB. Okay. Let's see what else. Same thing for the data model that it's due on the 23rd, right? You can absolutely use any backend you want, right? If you want to try out again Django, or if because you prefer Python as a programming language, then feel free to do that. Or if you've played around with a little bit with C# and the .NET framework, then the entity library is very powerful to as a competitor or as an alternative to JPA and ORM in Java. Certainly feel free to do that as well. And also for the front end, right? If you're not, please don't feel that you have to use what I gave you. Mine was a React.js primer, kind of like 25 words or less on React.js, and there's plenty to say there. Obviously, there's a whole course on it that I teach separately. But if you feel more comfortable using some other user interface solution, then obviously feel free to explore that. So if some folks are exploring using Django, other folks are exploring using Angular, other folks are even doing a mobile application or tablet application or even a desktop application. Again, it's much more open-ended, and you're free to choose for the project. Okay. There are some requirements, minimum requirements that we went over a couple weeks ago. We'll go over again today. And so the way we're gonna spend the next couple weeks is that I'll first have the first half or first 2/3 of the lecture. It'll be specific to a topic that I feel is useful for your project. And then the last third, or maybe last half of the lecture, I'm going to leave it open-ended, and we'll ask you if you have something specific that you want to discuss in lecture. Maybe you have some challenging topics that might be useful to share with the rest of the class. So please, if you have some questions, some that are fairly general that are useful to find might be useful for everyone else, please share with us and we can discuss it. Also, if you want to reach out to me first independently, privately, do that as well, and we can incorporate that in our lectures. I don't want it to become an additional just office hours where you might have something that's not working or it's not, or you have a bug or you have something's crashing or some environmental issue. That's not, we're not going to cover that in lecture, right? So if it's something very specific to you or your team, then I'd rather do that offline and during office hours or one-on-one. What I'd like to for you to come with questions and concerns or challenges that might be useful for the rest of the class. If you absolutely have nothing that you want to discuss, I certainly have much more material. I can just continue chatting and showing you more and more things on building applications. So, but yeah, so the next 2 or 3 weeks, 2.5 weeks, no, at least 2 weeks, we're going to be focusing on how do we bring everything that we've learned in the last 2 months, 2 to 3 months. How do you bring it together to actually build an application, right? How to use databases, data-driven applications. Okay. So today specifically we will continue discussing MongoDB. We talked about how to interact with Mongo from the command line using the Mongo client, and we saw that we can use create, insert, update, delete, find to interact with the server. And so we'll do a little bit more of that. But the more interesting part is we want to be able to interact with it programmatically. So very much like we did earlier with Java, we use Java to be able to interact with MySQL using certain libraries, Java libraries, right? In our case, we use what it's called the JPA library. We also use JDBC. JDBC was a low-level library that allowed us to send commands, SQL, SQL commands to the server for being executed remotely on the database. We also looked at a higher level library called JPA that allowed us to think about the database in an object as objects, collections of objects. So we're going to do something similar today here with but with Mongo. As we saw, Mongo stores data formatted in JSON. It's becoming a increasingly popular format of storing data permanently. And so we're going to spend some more time there. How is it that we would interact with this this JSON format of permanent data storage, right? And so we'll talk about Mongoose. Mongoose is a very popular library that will allow us to interact with MongoDB programmatically. So that's will be the focus of today's lecture. Again, towards the end of the lecture, we're going to review the project. We're going to go over the requirements again, make sure we all understand what the requirements are. If you have any questions that we might answer and share with the rest of the class, please think of them and we'll cover them towards the end. You do have the NoSQL assignment due later this Friday. And again, that will be the last assignment, topic related assignment. You also had last Friday, you had the 7th quiz that was related to web development. And since that was a little bit off topic and was more towards, hey, did you work on the assignment and are you familiar with the assignment? And it was a untimed quiz. It had no time limit. It also had unlimited retries. So if you got something less than 100, please go back and try to get the 100 grade on it, right? Because you can keep doing it until you get the right answer. So yeah, so please practice that. But later this Friday there will be a quiz number 8. It's an optimization database. So it'll ask you questions about indexing, right? And the topic that we covered last week, we talked about transactions and we talked about indexing. So there's a couple questions on transactions. There's going to be a couple questions on indexing. On indexing, we'll ask you about unique indices versus non-unique indices and how each one can affect performance. And if you remember that unique indices usually are a good idea, that usually increases the performance of databases, a good amount, several orders of magnitude much faster if you have unique indices. If you have non-unique indices, it most of the time also increases performance, but not as dramatically as unique indices. And depending on how you structure the data, it can actually work against you, right? It can actually hinder your performance. You have to be careful there with non-unique indices. And we also discussed transactions. And so we're going to have a couple of questions on transactions, the different types of isolation levels, and the types of things that they fix, whether they fix repeatable reads or phantom reads, and the different isolation levels of serializable, repeatable reads, right? All the types of isolation levels and what do they fix? So be a couple questions on that as well. So that's upcoming this Friday. I just thought that we do need an additional quiz. So next Friday, not this coming Friday, but the next, the 16th, there will be a quiz on Mongo. And so, just to evaluate your proficiency in having used MongoDB in your assignment, and just make sure you're familiar with all the commands that you use in the assignment, the MongoDB assignment, your show DBs, your use a particular database, show your collections, insert into a collection, update a collection, delete a document, all the commands that we asked you to practice in your NoSQL assignment. Okay, so yeah, so that's upcoming next week. All right, so yeah, that's the plan for the next couple of weeks. For the last week, week number 14, on Tuesday, we will have an exam review. And then shortly after that, on that Friday, the exam will open up on Friday. It will be available over the weekend, right, and probably till Monday, right? So you'll have a good 3 days where you can take the final exam, same format as the midterm, right? It's all going to be online. It's mostly fill in the blanks, multiple choice, and it covers the entire material of the course, right? So everything from the first half of the course plus the second half of the course. Definitely no web related questions whatsoever. Okay, so definitely no React or anything like that at all. But you will have some ORM questions, so definitely just brush up on entities and repositories and .save, .find, things like that. So definitely brush up on that. Definitely Mongo related question, definitely transactions and indexes, plus all the stuff that we covered in previous in first half of the semester. Okay. So anyway, that's the plan for the next couple of weeks. Any questions? All right. If there are no questions, I'm going to continue with the material. We will come back to the requirements. Actually, no. Let me cover the requirements before we continue. Make sure that everybody understands these requirements. Yeah. So again, the final project is a chance for you to work in a team and apply everything you've learned throughout the last 2 or 3 months of creating database, designing databases, and apply it to a domain of your choice, right? A topic of your choice, right? In our assignments, right, we chose the topic of social networks, social networking, right, where we have blogs and posts, and you have users that create these blogs and follow them and review them and thumbs up, thumbs down, things like that, right? So that was a topic of choice. And for the project, you are free to choose your topic. Now, I refer to these topics as domains, right? The domain object, right? What is that your preferred topic of discussion is, right? So you get to choose that. Also, it's much more open-ended than the assignments. In the assignments, we forced you to use MySQL. We forced you to use Java. We forced you to use React.js or MongoDB. Whereas in the final project, you are free to explore other alternatives, right? Whereas the concepts will be the same, right? The minutia, the details will be different, right? For whatever it is that you choose, whatever technology stack you choose, it will be different, but conceptually they will be the same. So there are a couple of minimum requirements, and feel free to go beyond these requirements, but you do need to come up with a data model, and the data model needs to be documented as a UML class diagram. So one single UML class diagram. It should contain all your classes. Your classes should have names. You should have properties. Each property should have its own primitive data type. It should have also relationships between the classes represented as lines. Those lines should have cardinality, right? One to many, many to many, whatnot. You should also have whether they're aggregations or compositions, and so it should have a full, complete UML class diagram. Now, you should reify the diagram with the intention that you will be implementing this class diagram as a relational database, right? So that if you do have two classes that are related to one another in a many-to-many relationship, you have to remember that even though you can draw it on paper and it is a proper UML class diagram, right? It cannot be implemented using a relational database, right? So you need to reify it. So two classes will be converted into three tables, right? And with one-to-many relationships between the mapping table and the original two classes, right? So yeah, so you need to reify it again with the intention of implementing it as a relational database. Also, there are some minimum requirements on the types of classes, right? So you need to have at least one class that represents a human being. Okay, this could be a cook, it could be an author that authors books, it could be a faculty, a student, it could be a sports fan, it could be whatever you want. Okay, something that is common in the topic or the domain of your choice, right? So if your topic is food, then a cook might be a valid human a human class, a class representing a human being. Now this user has to have at least the following properties: first name, last name, username, password, email, and date of birth. Feel free to add any additional fields, but at least these 6 are required. Okay. Then you need to have at least 2 non-human classes, right? These would be 2 classes that do not represent any human being, okay? And that they are specific to the topic or the domain of your choice, right? So for instance, if your topic or your domain is food, then a valid non-human object might be a recipe, right? Or an ingredient. Okay, those are non-humans, right? And they are specific to your topic. Okay, if your topic is movie, then movie is a valid non-human class, right? Also, a theater might be a valid non-human class, right? So again, it's your choice. You have to have at least 2 classes that are specific to your domain, right? And it has to be specific to your domain. It cannot be something generic, right, that can be used in any domain. Like, for instance, a review. So a review is way too generic, right? It's not specific to a movie. It's not specific to a recipe, right? I know you can review a movie, you can review a recipe, but review is not specific to the domain of your choice. Okay, so that doesn't count. You can have it, right, but it does not go into your bucket of required classes. Okay, so yeah, so at least 1 human class and at least 2 domain object classes. Okay. Also, you need to have relationships between these classes. You can have it is required to have at least 1 relationship between a human class and a non-human class, right? Or what I call a domain object, right? Between user and domain object relationship, right? So this might be, for instance, if you have an author, right? An author can author many books, right? Where the human class is author and the non-human class or the domain object is the book, right? And the relationship between the 2 is that the author writes books, right? So the writes is your relationship, right? And it's a one-to-many relationship, right? And one author writes many books, so it's a one-to-many. Or it could be a many-to-many, right? You can choose whether it's a one-to-many or many-to-many. And so, for instance, a many-to-many might be, you might have an actor, right, who acts or is part of the cast, right, in many movies, right? So that's a one-to-many from the point of view of the actor is acting in many movies. But from the point of view of the movie, right, the movie can have many actors in its cast. So it's a many-to-many between a human object and a non-human object. right? So you get to choose. You get to choose whether it's one-to-many or many-to-many, but it has to be between a user and a domain object. Okay. Next, you have to have at least one domain object to domain object relationship. All right. So these are relationships between a non-human class and another non-human class. Okay. And so for instance, if you have a song and have a playlist, right, that's a many-to-many relationship between a domain object song and a domain object playlist, right? You can have one song can appear in many playlists, right? And one playlist can have many songs, right? So that's again another example of a many-to-many between two non-human domain objects, okay? Optionally, you can have a relationship between a user and another user, right? This could be between a, for instance, if you have two classes, right? One could be a faculty, and the other one could be a student, right? And you can have a relationship. Maybe a faculty can advise a student, right? And so a faculty can advise many students. Yes, or you can have like a buyer and a seller, right? The seller, can sell to a buyer, right? Or the buyer can buy from the seller, and so that's a relationship between two human beings in two different classes. You could instead have relationships between records, right, in the same class. So kind of like a self-reference, right? And where you might establish maybe like a hierarchical relationship between users in that same table, right? Where, we might be all employees, right, in the employee table, but we all have the same manager, right? So all of us, 10 of us have the same manager, and that manager, along with 9 other managers, have one manager above them. And so you create this hierarchy of managers, right, in the same table. Again, that's another user-to-user relationship. Again, but that's optional. And so obviously you will not be penalized if you don't implement it. You will not get credit for it if you implement it, okay? So some might say, well, why even bother if I'm not going to get credit? It's actually a really good exercise, and I do encourage you to practice it anyway, even though you might not get credit for it. Also required is a portable enumeration. Now, if you remember, portable enumerations allowed us to declare tables that listed all the valid values for another field, right? Where you use the primary key as the list of all the valid values, and then in another table you had a foreign key that pointed to this table, so that that foreign key could only possibly have values taken from that enumeration table. Okay, so you have to have at least one portable enumeration. Just a couple examples. If a user has a field roles, right, and then roles could only possibly be either faculty, student, or staff, right? Those are the only possible values for role. Or say you have a movie has a field genre, so the only possible values of genre could be horror, comedy, drama, or sci-fi. Again, you get to choose what the enumeration is, and the valid values, it means something in your domain. So again, at least one portable enumeration. User interfaces, right? And so for every user class or domain object, you're gonna need at least two screens, right? So for instance, if your user data model is students, and then your domain objects are courses and sections, one human user and two non-human classes, right? One human class and two non-human classes. You would end up with 2 screens for students, 2 screens for courses, and 2 screens for sections, right? For the students, you would end up with a screen that you can list all the students, and then a field where you can edit the student. Then for courses, you need at least one list where you can list the courses, and the other where you can edit a single individual course. Then another screen that displays all the sections, and another screen that allows you to edit a particular section. Make sense? Yeah, so this is an example that you would need at least 6 screens. Deliverable. So I did add a section of deliverable. So let's go over what you are expected to deliver. And so first of all, we'll need your source code, right? And the best way for you to submit your source code, right? The best way is to use a Git repository or a repository. And so now I'm not quite sure how far along you are about knowing repositories, but certainly it's an invaluable tool that all software engineers should feel comfortable with. And I don't know if you've already been exposed to it or not. I can give you some pointers and do some tutorials to get you going. But it's the most effective way of sharing your source code with other software engineers. So the requirement here is that you will post or you'll share your source code in a repository, in a Git repository, which will contain all your source code. Okay. It will also have to include your database, right? So all the data that you have, all the data that you will be creating in your database, you'll need to share it with us as a zip file that will contain a directory that we can import that data into our local database. So dump all your data into a file, into a directory, and then zip that up and call it DB Design Final Project Database. Okay. And the other thing that we'll need from you is the UML diagram. You need to export it as a PDF document. Okay, and it will be also included in the source repository, and we need to be able to access it from there. Now the way to make it easy on the TAs and myself to be able to find everything, we're asking you to create a Readme file, right? So Readme files are very common, right? Just simple text files that live at the root of your repository. And in the Readme file, we will ask you to please provide the name of your project, the team members, right? The name of the teams, so this is if some students are spread over 2 sections. You have a couple of students in section 4. You have a couple of students in section 3, and they are collaborating. That's fine. We need to know all the students or teams that claim ownership over this directory, over this source code. Okay, because you will be graded on that source code, and everybody's going to get the same grade when we grade that project. So we need to know, right, who are the 4 that students, at most 4 students that are related to that project, and we need to know what teams you are in what section, right? So you might belong to team 1 in section 3, and or you might belong to team 2 in section 4. We need to know who's where in what section in what team. Okay, so please list all the team members and what teams and what section they belong to. All right. Also, in the README file, we'll need to know a very brief description of your project. Also, a link to the PDF document that contains your UML diagram. That's the deliverable P1. A description of your data model, right? That describes the the single user. Also, the description of your 2 non-human object models, right? Your domain object models. Also, a description of your user to domain object relationship and the relationship between a domain object and another domain object. So basically, the requirements in this document. All right. Also, a brief description of the portable enumeration, what the valid values are, and a description of your user interface. So there will be 6, at least 6 screens And so we need a maybe 1 or 2 line description of each one of your screens. Okay. All right. So that's the requirements. As I mentioned earlier, let me turn this off. As I mentioned earlier, the assignments, we're done with the assignments with for different topics. Okay, the remaining assignments are listed here are P1, P2, right, and P3. So P1 is available now, and some folks have already submitted, but it's definitely due on Friday the 16th. So again, we're asking you for a UML diagram and the database. Let me go over that real quick. The assignment says that you're going to design a UML class diagram based on the requirements that we just went over. You'll create a UML diagram, and you'll also implement that database as an actual SQL database that creates all the tables, right? And so you'll dump that schema to a file, to a directory, and then you'll share that with us by importing it in Canvas. Okay. So yeah, so that's this is due the 16th, right? So I think you have plenty of time to work on that, right? So that's due on the 16th. What else? Let's see. All right, any questions so far? Okay, so if no questions, we'll continue with the material that we worked on last week. Let's see, last week we created a directory where we played around with databases, Mongo database. So let me start up a PowerShell, and let me make that a little bigger. Okay. Let's see, we worked here. So we went to documents and new and databases and section 4. And this is the directory that we created for working in our MongoDB assignments. So we'll go in there. And this data directory is where we store the database, right? So to start the database server, we run mongod on the command line and then tell it where we want the to store the database, right? To store and retrieve data. So it is from this data directory that we created earlier last week. We say data. So that's going to start the server, and it's going to start listening for incoming requests at port 27017. So we're going to leave this alone. I'm going to minimize this and bring up another PowerShell. There we go. And so this one is going to be the client by which we are able to communicate with the server, right? So we can just start Mongo from anywhere. Let's start Mongo. So it connects to the server, and we can now issue commands to that server, right? We had created a couple things here. Let's show the databases. We had created this one, whiteboard 04, and let's see what we had in there. So we can say use whiteboard-04, and then here we had a couple collections. So show collections. We had users, sections, and modules. Let's see what data we had stored in there. Let's look at the users, db users.find.pretty. And that will comes up with a couple of records, right? Including Ada, Alice, and Tim Berners-Lee, right? So those were the 3 or 4 records that we had created last time. And we showed you how to do inserts, updates, deletes, finding by primary key, by non-keys, right? So if we want to build an application, right, interacting with this manually with the database is not going to cut it, right? So we need to learn how we can programmatically interact with the database, right? So to do that, we're going to introduce to you a new library that is able to connect to the database and start interacting it programmatically. So let's take a look at that library. The library is called Mongoose. Mongoose for Mongo, and it's very easy to start communicating with Mongo. You just load the library, which the library is called Mongoose, and then you use the connect function on the Mongoose variable and tell it where is the database running. And we know that usually the database is running on our local machine, localhost, and then usually listening at port 27017. Okay, this one is connecting to a database called test. We already know the database that we want to use. It's called whiteboard-04. And once you have a connection to a database, right, we can start interacting with it, right? So today we're going to spend some time learning how to use this library. Okay, now the library is very easy to use, right? The challenging part is that it's in a brand new language, or I think it's a new language for most of you, right? The language is called JavaScript, right? It actually has nothing to do with Java. It's a scripting language, and it's mostly known for web development, but it's grown, it's matured, and it's grown out of its shell and left the browser, and now it's a full-blown programming language that it's used for more than just web development. And in particular, it's used for connecting to non-relational databases, right, and storing data and retrieving data, and that's what we're going to be focusing on today. Okay, right. None of this is going to be required for any assignments or any quiz or any exam, right? We're not going to ask you to know Mongoose or any evaluation whatsoever. This content is mostly for those that might be interested in using Mongo as a database, and so they need to be able to communicate with the database, right? So I'm giving you a minimum set of skills that you'll need to connect to the database and start interacting with the database. All right. So so it's purely meant as an alternative for you to use it in your project. Okay. All right. So there we go. So let's get started. So we want to be able to execute JavaScript code on our desktop. Usually JavaScript is meant to be executed inside of a browser, but that's out of the scope from this course. Instead, we want to execute JavaScript right from our command line, right from our terminal. So to do that, we need to install Node.js. Right? So Node.js, if you head over to nodejs.org, Node.js is basically, it's a JavaScript interpreter, right? Just like many other languages are also interpreted in Python, Perl, Java to some extent, JavaScript, right? These are all interpreted languages that need a runtime executable that can interpret that scripting language, right? So we're going to be using JavaScript. So to be able to run this, you'll need to install Node.js, right? And by far, Node.js is one of the more exciting technologies today, and it's finding its way everywhere as an infrastructure tool for building and testing and automation. And it's definitely a great tool to have under your belt. I strongly encourage you to explore, beyond this course, on your own, become proficient with Node.js and whatever a non-relational database of your choice. But definitely Mongo is definitely a great place to get started in non-SQL. Anyway, so I've already installed Node.js. It's running on my machine. So when you install Node.js, you get two executables, right? just like in MySQL, you get MySQL D and MySQL. In Mongo, you get Mongo D and Mongo. Right here, you get also two commands that are very common. One is node itself. Node is the interpreter that knows how to execute JavaScript here at the command line in giving a file. And you also get NPM. NPM stands for Node Package Manager. And that's all discussed here, right? First, we're going to use NPM. NPM call its meaning is that it's a Node Package Manager, right? It manages packages, whatever that means. Basically, it allows us to build JavaScript projects, compile them, test them, deploy them, right? It's a build tool, okay? It's very much like in, for Java, the Maven. Maven is a build tool, a testing tool, packaging tool, right? That, but for Java. And every language, Python has one and Perl has one, right? They all have these package managers. So each language has one. So anyway, so let's get started. So first, let's open up our projects that we played around last week. So I'm going to close this and open up, open. And for section 4, we had created this MongoDB assignment. Let's open that up. And we're going to do most of our work in this directory. And I believe that's where we are in the PowerShell. Yes, we are. Anyway, so in here, let's create our very first JavaScript application, right? It's going to be so trivial that it's not going to do anything very interesting, okay? Now, the typical kind of application that most of us academics build for you, it's the hello world application, right? Its intent is to show you the absolute smallest and simplest application within a particular language or infrastructure. So, and usually it entails just printing out to the console the words "hello world." Okay, just to build up your confidence, right? That you can actually do this, right? So let's save that. Now let's run it. Now this is my Mongo client, so I'm going to leave that alone. Let me start up a new PowerShell. And let's go into that directory. So let's see, documents, NEU, and database design, and 04, and let's go into Mongo assignment. Okay, and notice that we have hello.js. There we go. So to run it, you just use node and then the file you want to run. There it is, right? So if we run it, notice that indeed it prints out hello world. There we go, the simplest of Node.js applications. Okay, let's explore something much more interesting. So we want to be able to communicate with the database, right? We want to be able to issue all these commands, all these finds and inserts and updates and deletes. We don't want to do it from the command line. We want to be able to do it from an application, right? So how do we do that? Well, first of all, we need the library. We need the Mongoose library. Okay, so we need to bring over that Mongoose library. We need to download that library and install it locally on our machine. Right. So to do that, first, we need to initialize our project. We need to let Node.js know that we are not just in a directory, right? In any directory, we are actually inside of a Node.js application, right? And we do that with the npm tool, right? And we say npm init, right? So let's do that. So in here, we say we are in the correct directory. We say npm. So let's look at the content first. We just have data, dump, and hello. Okay, so let's do npm init. Okay, so npm init kicks off a wizard, right? That's going to ask us a couple of questions about the project we want to create, the Node.js project. So it's suggesting that this would be a good name for the project, is basing it off of the name of the folder. And that's fine. This could work. I'm going to actually use a different name. I call it DB, right, for our database design course. and then dash the SP21, that's spring 21, followed by the section 04. And also I'm going to capture in this name the fact that we are doing something with Mongo and something with Node. All right, so I'm going to say maybe Mongo and then Node. Okay. Okay, let's create that. And now what version is this? So by default is version 1. Let's keep that description. So it's a simple Node application connecting to Mongo. Okay. Entry point, no entry point. I guess hello could be it. Test commands, I don't have any tests. Git repository, I am going to share with you this code in Git, so you can then pull it down and use it for your own purposes. Again, you're free to ignore everything that we're talking about today, but I think it's a great starting tool where you can decide to use this that we're going to be talking about today as your project, right? And we showed you how to do it with Java. We showed you how to do it with React.js and with MySQL. Now we're showing you how to do it with non-relational databases with Mongo and Mongoose as the application for interacting with the database. Okay. So yeah, so I will share all this code with you, and you're free to use it or entirely ignore it. So I'll update this a little later. Keywords, this is Mongo, this is Node. Author, it's me, so Jose Annunziata. And license, and there it is, Jose. There we go. Now notice that what it does is that it creates this new file that was not there before, right? So this file, if you look at the content, it's just basically a JSON file, right? It's a JSON file, and it just describes this project. Okay, it gives it a name, a small description, and whatnot. That's it. Okay. Now this package JSON, it's equivalent to pom.xml in Java, right? If you remember, in Java application, we were using pom.xml. It's a very common configuration file that describes Java projects, right? So the equivalent here is this package JSON file. Okay. Okay. Right. So we have our Node.js project. Excellent. So now that we have a Node.js project, we can start downloading libraries that we need, right? In particular, we need Mongo. All right, so let's bring Mongo over. Let's install it. Let's go to the content of the directory. Notice that we just have data, dump, hello.js, and package.json. So let's install Mongoose, right? Like this, npm Mongoose, npm install Mongoose. So let's paste that, do enter. So this is going to go out into a code repository that is public to everybody, right? And downloads the Mongoose library and installs it locally on our machine. We do an ls, you'll notice that now we have an additional directory called node_modules, okay? And so it copies down those libraries and it dumps them into your directory, node_modules, okay? All right, so great. So we have Mongoose already installed. Now we can start using it to connect to the database, right? So let's do that. So to connect to the database, Mongoose already has some sample code that can accomplish that, right? And these first two lines are the key to connecting to a database. Let me copy that and let me bring it over to our hello.js. I'm just going to replace it with our content here, right? And let's go over this code. Okay. So the first line, you'll notice that it says that it's requiring Mongoose, right? What's all that about? Well, require is very similar to what you would do in other languages, such as import, right, or include in other languages. And basically, what it does is that it loads into memory, other APIs or other libraries, right? It makes them available in your local space, right? And what we're doing here is that we're assigning to a local constant variable, right, whatever this module is exporting. So modules export something, and then we can import it by using the require command, right? So now we have the Mongoose library all ready to go as part of that variable. Make sense? All right. So one of the commands in the Mongoose library is the connect command, and it does exactly what you think it does, right? It connects to the database, right? All right, and has the following syntax, right? It has a couple of arguments. The first argument is the most important. It's a string. It's the connection string, right? It's very similar to what we used a couple of weeks ago when we tried to communicate with MySQL. Remember MySQL? Remember that? Right? That allowed us to communicate with MySQL. But Mongoose doesn't know how to talk to MySQL. It only knows how to talk to MongoDB, right? That's its only reason of being. So this first part of a connection string is usually referred to as the protocol, right? So meaning it's a specific language that we're talking either to MySQL or Oracle or SQL Server or MongoDB, right? So this is the language of MongoDB. Then followed by the host or the IP address or wherever the server is supposed to be running, executing, waiting for an incoming connection, right? Usually, just when you're developing, this is localhost or 127.0.0.1. And so that you can start communicating. And then the third item here is the port number where the server is listening at, which is, we know it's listening at 27,017. Finally, the last piece is the database that you want to connect to. And we know that we have a couple of databases there. You can say show DBs, right? Show DBs. And we have whiteboard was for the other section, and we have whiteboard 04, right, that we can use here that we know that we're going to connect to. So whiteboard 04. There we go. There we go. So now we are this, by running this, we will have been connected to the Mongo database. Perfect. Everybody okay? You're still with me? All right, so this connects us to a database, and now we want to be able to start talking to the database. So how do we talk to the database? Okay. So very much like when we did this in Java, we remember that we had a couple of options on how to talk to a database, right? We had JDBC, which provided low-level interface with the database where you could literally send a command, a SQL command, to be executed in the remote server. Okay, and then you have an API such as execute update or execute query, right? The query was to execute select statements, whereas updates were for update, delete, and insert, right? Now, we don't have anything like that in Mongo, right? Instead, what we've been using so far are things such as, db dot collection dot find dot update dot insert dot delete, right? So they're not as low level as select statements or queries or inserts in relational databases. Instead, if you remember, we used something a little bit more advanced. We used the ORMs, right? The JPA library that allowed us to have a generic objects, right? That could save, right? Could delete, could find all, could find by ID, right? So provided all these generic functions that allowed us to interact with a remote table. So this is more key to what we're doing here, right? Where we have .find, .update, .delete, whatever, right? And so we want to be able to use something like that, and that's what Mongoose is going to give us, right? It's going to allow us to use almost the same kinds of commands that we've been using at the command line, but at the application level. So how do we do that? So the first step is to define the schema, and define the schema. Now, if you remember, we had said that we have no schema in the database, right? That you were free in the Mongo database, right, to have different schemas even for each one of the documents, right? That there was no validation, right? That even though the two fields might be called the same, you can have different data types, or they could be spelled differently, right? There was no validation, and that's true. at the database level, the MongoDB instance is not going to be responsible for doing any of that. Okay. Instead, the responsibility is going to fall on the application level, meaning here. Okay, we are at the application level. We're building the application. So instead of having the database be responsible for doing all that validation, instead it is going to be the responsibility at the application level to do all that validation. Okay. So let me show you how you would do that. Right? Remember, in a relational database, it is very, very important. It is the focus of the database to enforce the structure, right, and the validity of the structure of those relationships, of all those data types. Here, Mongo is not doing anything like that, right? It's not doing the validation that a particular field is of a particular data type. None of that, right? It's not enforcing that, you know, if I have a reference to another record, it's not enforcing referential integrity. Things that were fundamental in the relational database are not as fundamental in the non-relational database, right? So instead of having the database have the responsibility of validating data types, validating relationships, validating pointers and references and foreign keys and primary keys, right? Instead of falling that on the database, that is going to migrate over to the application level. So let me show you how you would do that at the application level. Okay, so we're not going to declare a schema at the Mongo database, but we're going to declare it here at the application level. And the way we're going to do that is as follows. Let's look at the collections we want to interact with. So let's look at the students, for instance. If you look at the students, we see that it looks like students have a first name. Notice that both of these have first names. This last one did not have a first name, but maybe because it's not a required field. Looks like they have last names, usernames, right? Looks like everybody's got a username, right? Password maybe here there was an error and we didn't enter the password. Looks like they all have like this kind of like type. Okay, so we have been following kind of like a structure for our data, right? So we can formalize that structure by creating a Mongoose schema, right? That we can then use to validate any data that we want to insert or update. We can always validate any new data or any new updates, right? Validated against that schema so that we're not littering the database with garbage, okay? Because we know the database is not gonna validate any of this. We're gonna do it at the application level. So let's do that. We're gonna declare a schema for the user. We'll call it user schema. Okay, and we're going to use this to validate our data when we insert or update something. So to create a schema, we use the Mongoose library, right? And we use the function schema. There it is. So dot schema, and this allows us to instantiate a brand new schema as follows. Right? You can provide the schema as a name value pair JSON object. That is as follows, right? We're going to list on the left-hand side. We're going to list the fields, right, or the properties, field, and then the type on the right-hand side. Okay, so that's going to be the pattern: field type. So these are going to be keys, values, The keys are going to define the fields, and the type is going to find the type. The value is going to define the type, right? Very much like how we're here, we have a key, and then this will be a string. A key, and this will be a string, right? I guess we only had strings. A student should have a GPA, which was a number, right? So anyway, so let's do that. So some of the fields that we want are first name, right? And the type is that they are a string, right? Notice the capital string S. And then we have a last name string also. We have a username also a string, and password is also a string. Right. All right. There's a whole bunch of other fields, but we'll come back to that a little later. But notice that by at least providing the data type, already we are better, right? We are already able to enforce the fact that these are a specific data type. Whereas here we were able to insert whatever we want at the command line, right? There was no validation whatsoever. Whereas here, by declaring that first name is a string, it would not let us insert a number or a date, okay, or a Boolean, right? It would not allow us to do that. It has to be a string. Another configuration that we can use here as part of the declaration of the schema is that we can specify the collection that we are connecting to within a specific database. So here we specify that this is that database, right? Whiteboard 04. And then we can also specify the collection within that database. And we can say we want to be connected to the users collection, okay? Meaning this collection right here, the db.users, okay? All right, so there it is. That's the schema, right? The structure of the data that we're going to be manipulating. Beyond that, we need to also declare what we call a model, right? So a model or a Mongoose model, this is the equivalent of if you remember in the ORM, to be able to talk to the database, we had to create what are called a repository. Remember the Crud repository? So that allowed us to configure what it is that we want to CRUD, right? In our case, we want to CRUD users. We want to create, read, update, delete users, right? In the case of Java, right, we used an interface. We provided the actual class that we want to CRUD, and that maps to the table that we wanted to store or connect to, right? And then once we have the repository provided all sorts of really cool functions, generic functions that allowed us to save, find all, find by ID, delete by ID, right? Update and save, right? So the repository provided us with generic functions. So that's the Mongoose can do something similar, right? So Mongoose, we don't call them repositories in Mongoose, we call them models. So here we'll create a user model, right? And this is going to be the equivalent of a repository, right? And we create a model by saying Mongoose model, okay? And then model takes two arguments. The first one is a string, and the other one is the schema, right? The user schema, right? And this is eerily similar to what we did in Java, right? Again, same concept, different syntax, right? Different language, but it's the same exact concept, right? The first argument is just a unique identifier. You can call it whatever you want, but a very common naming convention is that you declare the thing that you are CRUDing. We are CRUDing users, and then followed by model, right? So this is not as important, right? But the second one is important. We're saying that it is the schema that we want to CRUD. Notice that it tells us what collection to use. See that? And it tells us all the fields and the data types. Very, very similar to what the Crud repository did. Remember that? In the repository, it asked us for the class, which is the equivalent of the schema. Yeah, because the class tells you all the fields, right? And also the class in the repository, right, also told you what table it mapped to, right? Either the default name of the class or by using the at table. Well, that's very, very similar to what we're doing here, the collection users, right? We're saying that we want to store the data or retrieve the data from a collection called users in the database. See that? So this is very, very similar conceptually to what we did in Java, right? And any language that you choose, Python, Perl, PHP, Ruby on Rails, whatever language you choose, right? It'll be a different syntax. It'll be a different language. It'll be, different idiosyncrasies, right? And maybe some of them uses files, other uses XML, other ones uses whatever. But conceptually, they all do the same exact thing. Okay, and once you've had a chance to apply this using multiple infrastructures, and you start seeing a pattern, right? And you start seeing, oh, everything's the same, right? Whatever language you throw at me, just let me take a look at how it is that you do things. Everyone has its own idioms, right? Obviously, it has a learning curve, just like learning any language. If you're going from English to Spanish to French to Japanese, right? Obviously, each one has its own learning curve, but obviously at the end, you will be able to say same things, but in different phonemes. Yes. All right. So user model, basically, user model is going to give us all the commands for interacting with the non-relational database. Okay, so user model. All right, excellent. So we're ready to start talking to the database, right? Are we ready to go? Let's do it. Okay, any questions so far? All right, so let's do our very first interaction with the database. So one of the easiest things we would like to be able to do is do a find, right? Users.find.pretty. Okay, and we're expecting this array, right, or a collection of multiple objects, 1, 2, 3, 4 users. Okay, all right, let's do it. Now here, user model is the equivalent of this db.users. Okay, so the user model is playing the same role as the db.users now, right? It is connected to that collection, right? And now you can start issuing commands to it, right? And what the team in Mongoose did is that they tried to keep the names of the operations the same as the functions that you can issue at the command line, right? Also, the parameters that you can pass, they also try to, pretty much follow the same signature, right? So that it looks very, very similar to what you would do at the command line, but from the application. Okay, so let me show you. So for instance, one of the things that you could do is user model dot find. Guess what that does, right? This does exactly what this does, right? Without the pretty, right? Actually including the pretty. This includes pretty, right? So let's do it. Let's run it. Now, if you run it now, right, and we know how to run it, right? We can let's see, go here, and we're going to run node hello. Now, if I run it, notice that it doesn't do anything, right? And that's because it actually did connect to a database. It actually fetched data, but we never told it what to do with the data, right? It fetched the data and says, well, what do I do with this data, right? So let's tell it what to do with the data. Okay, so the way this works, it actually has two different syntax. Okay, let me show you the first syntax. The first syntax is that the find function wants to report to you what's the data that came back from the server. Okay, and the way it reports it to you is that you have to give it a kind of like a callback function, where it's once it goes and fetches the data, right, and then can pass you the data that came back from the server, right? And we can use the following syntax. So it could be function, okay, and this function will be, it's an anonymous function, it's an embedded function, and it's going to pass you the data, or it's going to pass you some error, whether something went wrong, the connection was lost, whatever, right, or timed out. So this function gets invoked with two things. One, if there was an error, it'll report the error as the first argument. And then if any data came back from the server, it's going to pass it to you as the second argument. See that? Right? Okay, so let's print both of them. Let's say console log the error. Hopefully this error is null. There were no errors. Or we can print out also the data. One of these will be null, right? Hopefully the error is null and the data is not null. Okay, so let's run it again from the command line. Let's run it. There we go. Notice that we get exactly what we got from the database, right? If we go back to Mongo, notice that it's exactly the same data. See that? The only difference is that because this is being loaded into memory as a variable, the data variable, right? If it comes back as a collection, as a set of things, the way you represent that in JSON is as an array, right? As opposed to here, notice that this doesn't come back as an array. It's just just objects, printing object after object, right? Here it's collecting all the objects instead of an array of objects. Make sense? Okay. Excellent. There it is. So that's our very first find all, find everything, right? Now this syntax. This syntax is it's kind of like an older syntax in JavaScript. It has since well, it's still widely used, but a more modern version of this drops the function keyword and instead replaces it with an arrow here. Okay, this is becoming more and more popular in programming languages. Certainly Java has a version of this. C# has a version of this, of arrow functions, right? They're much more terse, right? They're and easier to embed, right? As opposed to writing the whole function keyword, right? And if I save this, this will run. It'll do exactly the same thing, right? It just prints out the content. Okay, everybody good? Everybody still with me? Yeah. So commonly, we usually don't have. Usually, what we want to do is we want to wrap this functionality inside of a reusable function, right? That encapsulates this functionality into something meaningful, right? So, for instance, we might, instead of using it like this, instead we would create a wrapper function, right? That had a meaningful name, like for instance, find all users, right? That's a meaningful name. And so we wrap this whole thing inside a function like that. Okay, so now we can call this repeatedly, and other folks in the application, instead of calling user model.find blah 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 blah, right? They can just call find all users. It makes much more sense. So we can call it like that, find all users. Right, and if you run it, it does exactly the same thing, but at least now it has a more readable and understandable name. We've encapsulated the details here. Yes. Okay, so let's play around with something else. Let's retrieve users, not all of them. Here we have a whole bunch of users. Let's retrieve a user by their username. How about that? Let's do that. So we'll do something like user model dot find. Okay, and the way we would do it at the here at the command line using Mongo, we would do something like db dot users dot find, and we would provide the predicate here. We would say something like users or username colon, and then the username that we want, for instance, Alice. All right, so let's try Alice. Right, and then dot pretty. There it is. So we're able to return the Alice user, right, by their username. So let's try and do something similar, but in Mongo, by using Mongoose. So again, it's the same, almost the identical API here, but using it programmatically, we use curly bracket, and the field we want to filter by username, and we'll say Alice. But right, we need a place to store this content, right, of retrieving the data. And again, it's a function. This takes a function, takes an anonymous function where the first argument, just like before, right, is going to be the error and the data. Right, so let's do that. That's error and data. And then we can do a console log the data. Okay. All right, let's try it out. Let's run that. And there it is. There's Alice. See that? It comes back with the Alice. Notice there's only one object. We know because that's username is unique. It's a unique identifier. Okay. Actually, well, first of all, let's wrap this inside of a function. Right, so it's be const find user by username. Okay, and this can take as argument the username, and then right, the function can then use that as an argument, and you can pass it as an argument here. Right, and now you can find user by username, and let's come back with what user. Let's see. Instead of Alice, let's do Ada Lovelace. A Lovelace. So this would be A Lovelace. Okay. All right, let's try it out. There it is. So it returns A Lovelace. Okay. All right. Okay, but notice that that here we have an array, and we know that username, right, typically would be a unique. Right, so we know this is not a primary key, but we know it's unique. So we know that it should only ever return 1, right? And notice that it's returning an array of 1, okay? Because find always returns an array, regardless, even if it's just one element, okay? So it'd be nice if we could, we could treat it indeed as if it were one single object. So for that, we have another finder method. Right, so you have, let's comment this out. You have user model. If we know that we're going to find something and there's only one, right? Because we know that the field that we're going to use is a unique field, right? And we know that we can say, username colon username, right? Okay, so this is a different implementation of the same thing. Okay, and then the callback. So I guess let me copy this. Copy this. Right, so it's the same one. I'll call it find user. Find one user. How's that? Find one user by username. Okay, and so this will, instead of find, it'll be find one. Okay, find one. So if we run that, find one user by username, and we're going to pass in, let's see, T Lee maybe. I don't know if we have them in there. Let's try it out. Okay, notice that now it's not coming back as an array, right? Because we know that username is unique. There's no point in putting in an array because we know there's only one of them. So it unwraps it from the array and just gives it that one object. Make sense? So find one is, it's syntactic sugar, right? It's basically this, but unwrapping the only element, right, and just printing that out. Okay. All right. Let's now return something by its primary key. Right? So for instance, what we might want to do is find a user, right, by the primary key. So by their ID. All right. So you're going to pass in the ID, and the implementation will be something like user model dot find. Right? You can always use find. And this would be the field would be underscore ID colon the ID. Okay. Notice that the way we would implement it here in the database would be that you would do something like db.users.find, and this would be the ID colon. Notice that we wanted Alice right? If we had the string, and let's see if we can paste it. No, we can't paste it. I don't want to do Control C and then it's going to kick me out. Wait, can we Control C? Oh, we do it. Okay, here we go. ID. Notice that it doesn't come back with anything, right? Because we need to wrap it inside object ID. See that? It's kind of cumbersome. Okay, there it is. So it returns something. But here in Mongoose, right? Let's see that. Oh, we need to put it. I'm sorry, we need to put it inside of a JSON object, obviously. Okay. Notice that it's going to let me just use this as a string, and so it doesn't force me to wrap it inside an object ID. I mean, I can, right? But I don't have to. It does that for me automatically, right? So again, this is the error and the data, and we're just going to display this. I'm going to do console.log data, right? And we're going to try it out. We're going to do find user by ID, and let's try out this guy right here. Let's copy that, and I'm going to paste it in here. And let's run this from the command line. There it is. It returns Alice as promised. Right, so that's nice. That's nice, right? At least we can just work with plain old strings. We don't have to wrap it inside object ID. That's very convenient. But again, notice that even though it's using a primary key, it's still returning an array. Again, find always returns an array, even if it's one single object, right? So there's a syntactic sugar to deal with that, right? So we can, let's copy this. Let me show you, right? And let's paste this. So find user by ID has another version. Find by ID, find one user by ID. Okay, and this version is called find by ID. It's called find by ID. Now, if it's find by ID, it's redundant that you tell me that you're filtering by the ID. Right? I know that what you're passing me is already an ID, so you don't have to tell me that this is a JSON object that contains the ID. Just give me the ID. Okay, and if I do that, right, I can do find one user by ID. Let's try it out. Let's use another user. Let's see. Let's try Ada. So let's copy this here. Copy. And we'll paste it in here, right? And let's run it. And there it is, Ada. Okay. Yeah. So there it is. So I mean, there's a whole bunch of other finders, right? That that you can write depending on what it is that you're looking for in the database, right? Everything that you can do in the command line, you can definitely do here. Let's now play around with other commands, right? So for instance, let's delete a couple things, right? So for instance, and let's find all the users. Let's remove this user, right? Because it's kind of bogus, right? It only has the type, right? Probably some error that I have, right? So let's remove it by the ID. Okay, let's remove it by this ID. So let's copy that. So how do we remove it? So let's implement a function that says const delete user by their ID. All right, so you're going to give me the ID, and it's going to be user model has a function, just like you would do it here in the here you would do something like this, right? You would do db.users.remove, right? And then you would say underscore ID colon, right? Object ID blah blah blah, right? And then you put the whatever ID here is, and then you would run that, right? And yeah, I used a bogus ID that doesn't exist, right? So the same way I can implement it here. User model provides a function just like from the command line called remove, right? Which the first one is the filter, right? We want to remove a user whose ID matches the ID that you're passing as an argument, okay? And then, right, the second argument, you need the second argument, even if you don't intend to do anything with it, you always need that second function here, right? So it would do error, and now it's not the data, right? It doesn't pass you data. Instead, it passes you a status information, whether the removal succeeded or not, right? So because it makes no sense to pass you data because you just removed the data. It's gone. The record is gone, right? Instead, it passes you a status object telling you whether it succeeded or not. So we're going to do console log the status. Okay. All right, let's try it out. Let's do delete user by ID. And let's remove this one right here, this ID. Let's remove that. Let's copy that. And let's paste it right there. And let's run it. Save that. And let's do the command line, run that. Okay, notice that there it is. It came back, deleted count, that indeed it deleted something. Okay, so it gave us some feedback that it succeeded. If we go to the Mongo and we do a find again, we'll notice that that record is no longer there, right? Notice that that bogus record is gone, right? So it succeeded. How about updating something? Let's change Alice's name, right? Username. We'll change her username and her first name. Let's do that. So let's comment this out for now. So to update, right, at the command line, you would do something like db.users, right, dot update, and then you provide two arguments. The first argument is by the filter, right? Maybe the ID that you want to update, and then here you would say, $ set, and then all the fields that you want to set. Maybe the first name, right? You want to change the first name, and then the username you want to change it to something else, right? Whatever. Okay. It's not going to work because obviously the ID is bogus. But this is exactly what you would do here as well, right? You would do something like, const, update user by ID, and you would provide maybe the ID as an argument, and also the new user values. Okay, and so you would use the user model again, the same syntax. You have the two objects, right? One is the filter, the other one is the new data, plus the function, right? You always need the function at the end, right? And this will be, error and the status, right? And we're gonna print out the status, log the status. Okay, so here, right here is going to be, I'm going to change the user whose ID matches that ID. And what am I going to change? I'm going to do a set, right? I'm going to set what? Set the first name. I'm going to change it to new user values dot first name. You're going to give me the new value for the first name. You're also going to give me a new username, right? New user values dot username. Okay. All right, let's try it out. So we want to change Alice. So Alice, that's the ID. So let's copy that. And let's call it. Let's say update user by ID. There's the ID, right? And I'm going to pass you a new object. I'm going to give you a new first name. So instead of Alice, it'll be Alicia. And instead of username, Alice is also going to be Alicia. Okay. All right. Let's run this. Let's see. Run that. Notice that it said that looks like it was successful. Let's go into the database and let's print out all the users. And indeed, Alicia worked, but first, fist name. Fist name. So I got it wrong. Sorry. So this will be fist name. Let me try that again. And let's run that again. Okay. Did it work? I don't know. Alice Fist. Am I spelling it right? Fist name, blah, blah, blah. First name. Well, anyway, yes, it would work. Making sure that, definitely things match. Finally, let me show you about creating new documents, right? Creating new documents. So for instance, I would like to be able to create a new user, right? Where you provide me with a new user object, okay? Now here's where the code deviates a little bit from the way you do it in Mongo, right? In Mongo, you would do something like db.users.insert, right? And then you provide whatever new object you want to insert, right? In Mongoose, it's slightly different, but not much different. You use user model dot create. Instead of insert, it's create, right? That's basically the only difference, right? You get the new user that you want to insert, and the object that the function that you always have, right, is the one where you have, whether you get an error, and the data. Now the data here is going to be the actual record that was inserted into the database, right? So for instance, if you do console log the data, it's going to be the brand new document that was inserted. Okay, so let's try it out. We're going to do insert or create. We're going to do create user, and the new object is going to be first name. Let's see, what user do we have? We have Tim Berners-Lee, Alice, Ada. Okay, let's insert a couple others. So let's insert Bob, and last name Hope. Bob Hope. Let's insert that one, and let's try it out. Let's run it. Let's see, run. There it is. So notice that it indeed inserted Bob. Notice that we got a brand new ID. This __v is for Mongoose. Mongoose is keeping track of any objects that it creates, just like Mongo creates this _ID for any objects that are inserted. Mongoose also has its own variables to keep track of versions of the objects. Let's insert another one. This is Charlie Garcia. Here we go. Let's insert, and maybe the username and C Garcia, and let's run it. And there we go. Inserted Charlie Garcia, and from here we can display the new users, and notice that indeed we have Bob and we have Charlie. See that? All right, so I am going to share this as a repository, and this will be the beginning of sample code that you can use, again, for your project. Again, you could use either Java and MySQL, or you can use JavaScript and Mongoose, okay? Or if you prefer Python, I don't have a Python startup code here. But if you want to find, there's a few out there, repositories that you can find where to get started on Python or Perl or any other language that you want to try out. Okay. All right. So yeah, next week on Friday, please come with questions about the project, any challenges that you might be facing, anything that you might want to share with the rest of the class. Again, if you don't have anything, I'm just going to keep going, right, with more material. But I do want to give you a chance to, to share your experience and any challenges that you might be facing, and we can address them and perhaps share them with the rest of the class. Okay. All right, folks. Thank you.
Thank you, Professor. Have a nice day.
Bye. You too.